All right, everybody, welcome back. In today's lesson, we are going to talk about Chapter 10 here, which starts with a couple of new functions that we have not discussed lately. We've had linear functions, we've had quadratic functions, and now we're going to talk about something called exponents and logs, which are basically inverses of each other, so basically opposite graphs of each other. So in this video, we're going to actually do 2 and 1 here. We're going to do A and B in this video alone, and then I'm going to come back, and if you notice, C kind of has that same sort of thing that we've seen a lot, modeling a set of data. So in actuality, C is not going to be anything new. We're just going to use our calculator to do a stat edit. So in this video, we want to talk about A and B, which is simply graphing. So as we look at these, we can see these are very, very complex. There's a lot of fractions and a lot of things going on here. And what we're going to do, we're going to actually try to simplify this as much as possible. And we're going to simplify it by making our graph just going back to, we make an XY table, and we're going to plug in some values and get an answer. And that's going to allow us to graph this much simpler than trying to memorize a set of rules. We want to think of graphing as simply the collection of a bunch of points. Excuse the bell there. But if I were to graph this, I would simply graph those points. And excuse the fact that that's not quite right because I'm just freehanding that. But that's all a graph is. We put a bunch of points on there and we connect the dots. And that's what I want to do for these exponential functions. So the first thing we want to realize is that this is that an exponential function has an x has its variable in the exponent, hence the name exponential. So when I look at this, I'm going to just treat this with an XY table. So I'm going to make my XY table, and we'll plug in some values and solve. Well, it turns out I don't need to do this by hand, do I? I have this tool in front of me, a calculator, that will actually allow me to find the XY table. So let's take a look at what my calculator does. Rather than write this all out, we can use the tools we have to our advantage. So I'm going to go ahead and do number 1, and we're going to start bring my calculator up here. So I'm going to go to my y equals. I'm going to do 5 times parenthesis. I need 1/2 in there. Now to get this whole thing in the exponent, I got to be a little careful. I have to do to the, and then I need to do x minus 2. And see how I put this in parentheses like this, x minus 2 in parentheses? That will ensure that that whole thing is in the exponent, and then I could just do minus 2 here. Now here's when I do the graph. You can see an exponential function does something like this. It basically either comes up or down and it curves down, but then stops here and goes this way forever. Stops here, goes this way forever. So that's what an exponential function looks like. And you can see this one's probably flipped around. A normal exponential function actually comes this way and goes up forever. So this one's actually backwards. That's okay. And what you can't do is simply take this and throw it on a graph like this. You can't just trace that. You have to actually come to your table. So second table. And let's go. See, it looks like at -2 it's too high. Right here is 18. So the first point I can actually get is 18. So I'm going to kind of, there we go. And let's go ahead. And I'll take a snapshot of this. Like so. So that's my table that now I'm working with. You'll notice I'm not really looking at the graph at all for this. The graph's just simply not that useful. We need these actual points so we can really get a good graph on here. What I say, we can't just do this and call it a day. That's not going to work. So the points I have now to graph are 0, 18, 1, 8, and 2, 3. And now we got to get a little careful because 3 is at 0.5. And then 4 was like down here at 0.75. And from there, we're kind of out of luck. So now I want to use my graph on the table, or on my calculator rather, and just come here and realize, okay, but it's going to kind of kick like that. And this is really the best we can do as a graph, like so. And that's really all I'm looking for. Do you have the maximum number of points available, and have you connected them, at least tried to connect them with a line? And that's all graphing an exponential function looks like. Simply put in your calculator and graph as many points as you possibly can, and then connect the dots. Your job is to match what your calculator shows you with the graph. So on number 3, I'm going to do -3 times 2 to the, don't forget parentheses here, x plus 1 is in parentheses, plus 1. So you see, this one's going the other way. That's fine. It's going to go like this. So I'm going to have my graph kind of looking like this. But again, I just want that as a reference. So it looks like -17, -19 is the biggest I can get. So that looks pretty good. Again, I'm just kind of, there's my graph. There's my table. And I'm just trying to pick the whole number point. I'm trying to pick the points that best fit on this graph. So when I say -19 was the best, because right here, that's the lowest that graph goes. So I can't go any lower. So I know right here, I'm not going to graph 2 because -23 would be off the graph. I can graph 1 at -11. I can graph 0 at -5. I can graph -2 at 0.5. Whoops. No, I'm all right. My bad. -1, I just missed -1 was at -2 there. That kind of threw me off a little bit. And -3, so it looks to me, and then I'm going to kind of remember that that was the general shape of that graph. So again, I'm kind of matching what the calculator graphed for me, but I'm also putting some coordinates on there so it looks pretty good. And all of these are now exponential functions. So we're using our calculator to get a table, and then we're graphing that table. When we get to 21, well, 23, I guess I went too far. Now we're doing something else. Now we're actually going through and graphing what's called a log function. And all a log function is the opposite, the inverse of an exponential. So it's going to be my exponential function, but flipped upside down. Again, we're going to do this the exact same way. And the reason we're doing it like this, and rather than, it's that the calculation by hand, you still would do the same thing. You would still literally find these points by hand and then plug it in. So it doesn't make much sense to not use our calculator here. Now, because it's a log, we want to use the logarithm button right there. And this is actually a lot easier to plug in. Whoops, I forgot my X though. You just need to be prepared that my graph's going to look a little weird. And you can see it is kind of the backwards of the exponential function. Now, one thing your calculator will not graph is it stops right here when in fact your log actually has this whole thing. So you do not want to copy here at all. We'll get to that in a second. When I go to my table, the same thing happens. Only now we've really got some problems here because you can see my log function just doesn't want to give me any points whatsoever. I got to start at -1 because at -2 is an error. So these are really the only points I can graph. And you can see it presents a pretty big challenge here because we're really going to have to be unexact on our graph here. We don't have any choice. If we did this by hand, it would be the same thing. So we're going to have to take a look here and really be careful on my graph and realize what's going on. So when I graphed -1, it was 5.4. So I'm going to go to 5 and 0.4 and just try to get that the best I can. When I go to 0, oh, I'm sorry, that was -1 though. -1 was 5.4. When I went to 0 is 5.8, so you can see it moved up a little bit. And 1 was about as close to 6 as possible. And you can see all of these values are basically right at 6. So I want to be very careful. I'm going to actually come out to 5. All the way over here, you're only at like halfway. So you can't do much with this, like I said. That's about as good as you can get. Now, your function does not simply stop there. What it does is it actually goes like this. And you can see that is different from what your calculator had graphed. Your calculator stopped the graph right here. Wherein I want you to graph that whole tail like that. So just be careful on that your calculator is not actually graphing that. As far as the points go, you can see we're literally using the decimal value here. So we're just trying to be a little judicious or a little exact on the decimal, but this is as close as we can really get to it without going to a lot of extremes here. So these are my graphs. Now, be prepared at any point that we're going to actually use these graphs in the future. So understanding where the x values and the y's and the coordinates, this is just our first step in all of this. Now, as we move forward, you will also see problems like 27 here. This is also a log function. It's still a logarithm. It's actually a special logarithm called the natural log. Now, for our purposes, it's going to act a lot like a log. You just need to realize that the button for natural log is right here. And then we'll do the exact same process. And you can see this one, hopefully, it's going to be a little easier to graph because it's not as flat. We're also going to recognize that when I graph this, I'm going to have this piece of my graph as well that my calculator doesn't put. But in order to do it, I'm literally going to come back to my table. Now, if I can get lucky, now again, there's still no points there. So the first point I can graph is really at -5. And it looks like it just keeps going up. So I'm going to start at -5 as far as the graph that I copy goes. And then I'm actually going to put the rest of this graph, so we have it both here so we can look at it. All right. So there's my table. And again, there's not a lot of help here. We can start to guesstimate a little bit. And again, this is all guesstimation, but we're doing it at least somewhat with a purpose. So -5 and 2.6 is going to go roughly right here. And that's my starting point. And then I can see that at -4, I'm already at 3. So I got to see that jump. You can't just put your points anywhere. It's got to be a little bit above 3. And at -3, it's also here. And then you can see at -2, now I'm above the 4. And I don't go to 5 till right here at 4, 5. So each of these is simply a little bit higher. And then I'm going to remember that this does, in fact, go like this. So see, I'm graphing the tail on that your calculator doesn't show. When I'm looking for my graph and when I'm grading yours, I'm looking for exactly what I just did. Obviously, you can't get real close, but here at -2, and this point right here, I know that -2 needs to be slightly above that 4. So that's what I'm looking for. I'm looking at -3 right here. Was this point a little bit below that line? And then was this point a little bit above that line? And if you got that for all of your points, then you're going to be fine. And then all you have to do, whoops, let's go this way. Where'd I go? There it is. There we go, my bad. And then all you have to do is draw in your graph by connecting those points. Okay, so in this section, we're simply practicing our graphing skills, and there's not a lot going on with it. So pause the video, or actually this video is going to stop here in a second. And I'm going to start a new video on part C of this, which is, can we use a stat edit to solve a problem? So when you're ready, go ahead and click on the next video.